Welcome to the future of factory automation.
This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM.
Today, we're diving deep into the whole discussion around industrial automation controllers.
Right, specifically looking at industrial PCs, IPCs, and, well, the traditional PLCs, programmable logic controllers.
And if you're listening, you're probably trying to figure out the best way forward for your own automation needs, maybe for a presentation or a project.
Or maybe you're just curious, trying to cut through some of the noise out there.
Exactly. So we'll be digging into the insights from industry pros in that original Japanese conversation to hopefully bring some clarity.
Yeah, and one thing that jumps out right away from looking at online comments and discussions is this growing trend, this recommendation to use IPCs. People are claiming all sorts of benefits.
Okay, yeah, I've seen that too. Let's unpack that a bit. What kinds of claims are we talking about?
Well, the big ones are versatility, right?
Yeah.
Running SQL servers directly on the controller, handling MQTT brokers, doing the actual PLC logic, of course, and even running code in, say, C# or Python.
Right, so the narrative is kind of the age of IPCs has arrived.
That's the feeling you get. But did the experts in the original discussion offer concrete examples?
Okay.
Or was it more theoretical?
That's a good question. Was it backed up with case studies where IPCs really made a difference?
That's where it gets a bit fuzzy. The enthusiasm is definitely there, both online and in the podcast discussion we're drawing from.
But maybe less on the how and why for specific scenarios.
Exactly. It often stays a bit high level regarding those broad capabilities, which naturally makes you ask.
Is it always practical or even needed for one controller to do all that stuff?
Precisely. The whole concept of over-specification comes up pretty quickly.
Yeah, it really does. Does every single control task need, high-spec PC hardware?
Especially the basic things, like just reading I/O signals.
Does a simple sensor input justify a powerful processor? Seems like overkill sometimes.
And another angle is safety. That's critical in this field.
Absolutely.
How does safety integration work with IPCs? How does it compare to the established certified ways we do it with PLCs?
You mean things like tube certification?
Exactly. Two of those German safety standards, they carry a lot of weight. How do IPCs stack up there?
That's a really crucial point because, honestly, despite all the buzz around IPCs, it feels like there's often a lack of really solid justification for just switching everything over. It's hard to pin down why they're universally better in every single case.
No, it really is. And that ties back to the over-spec thing again.
Right. Spending money on hardware capabilities you don't actually need.
That's money that could go elsewhere, couldn't it? Finding that sweet spot between performance and cost is, it's key.
And maybe we should even back up slightly. What is an IPC today in this automation context?
That's a good question. Is it just a regular PC in a tougher box?
The definition feels like it's getting blurrier, doesn't it?
It really does. And
Oh.
if you look at the bigger picture, there's this definite trend towards convergence.
Convergence between IPCs and PLCs.
High-end, mid-range, even some of the lower-end stuff. They're all starting to look more similar in terms of what they can actually do.
That's interesting because you take, say, Beckhoff or systems using Codeswise.
Popular platforms.
A lot of their sort of entry-level controllers, they don't run Windows, right?
Exactly right. They often use dedicated real-time operating systems.
So they can't just natively run an MQTT broker like a Windows IPC might.
Not in the same way, no. So choosing one of those doesn't automatically give you all those PC advantages people talk about.
Okay. But then when you move up to the mid-range and the high end,
That's where the lines really start to blur, as you said.
so the features most people actually need.
Maybe, 80% of typical automation tasks?
Yeah. Those features are increasingly available on both platforms.
That seems to be the direction. They're being built into both IPCs and PLCs.
So the fact that an IPC can run MQTT isn't such a huge deal anymore.
If newer PLCs are starting to offer that as standard too,
Exactly. The core functions themselves are becoming less of a unique selling point.
pretty much, as the tech evolves, yeah.
Okay, so if it's less about the individual features, what's the real differentiator then? What's the deciding factor becoming?
Well, I think it boils down to the underlying operating system. That seems to be the key divergence still.
Right. Windows or Linux on the IPC side.
Giving you that flexibility,
Yeah.
versus the dedicated real-time OSs historically found on PLCs.
So the ability to easily install and run, standard IT software on the IPC,
Yeah.
that's a major plus in some situations.
Definitely. That's a key advantage if you need that kind of integration directly on the controller.
But what about just keeping things separate. Use a PLC for the real-time control, the critical stuff, and then have a separate PC handle the IT tasks, talking to the PLC over the network.
That's a perfectly valid architecture for sure.
But it may be trickier to set up.
Historically, yeah. Integrating separate systems could be complex. That probably fueled some of the push towards the all-in-one IPC idea perceived simplicity.
Right, makes sense. So, looking forward, maybe the debate shouldn't be just IPC versus PLC, which is better now.
Maybe it should be more about defining what we need controllers to do in the future, what functionalities are essential.
Yeah, and the vendors, the automation companies, they'll likely keep developing both types of systems anyway, right?
Seems likely.
Yeah.
IPC-like systems, PLC-like systems, but with more and more overlapping features.
Were there any specific tech advances mentioned driving that?
Not in huge detail, but it's the usual suspects, right? Faster processors, more capable software, making it easier to bridge those gaps.
So for users, for you listening, what are the key things you'll need to weigh up when choosing?
Well, cost is always there, isn't it?
Always.
Scalability, how easily can the system grow? And importantly, do you need to run custom applications right there on the controller itself?
And if you do, the OS flexibility of an IPC becomes a big draw.
Exactly. That often tips the balance towards IPCs.
If your communication needs are pretty well defined and you don't have that strong need for lots of custom code on the controller,
then a traditional PLC might still be perfectly fine, right? Probably more cost-effective, too.
Yeah, the good enough approach.
Absolutely. We might see the gap widen again, perhaps, between basic, lean PLCs and these high-performance, super flexible IPCs.
Okay. And what about this huge trend, ITOT convergence? Bringing information tech and operational tech together. How do IPCs and PLCs fit there?
That's a really interesting point, because just picking an IPC doesn't magically solve ITOT integration.
Right. It's not just plug and play for IT concepts.
No. You still need fundamental IT knowledge, networking, security, data management. That's essential, whichever hardware you choose. An IPC doesn't give you a free pass on understanding IT principles.
That's a really important clarification. So, okay. If the hardware capabilities are getting closer and closer, where's the real battleground for vendors going to be?
It really looks like it's shifting towards the software development tools.
The quality and the features of the vendor's software environment.
Exactly. Think about platforms like TwinCat from Beckhoff or Mitsubishi Electric's GX Works.
How easy is it to use? How good are the libraries? How efficient is the whole development process?
Those become the critical factors.
And that leads directly into software modularity, doesn't it?
It does. This idea of using reusable software blocks, libraries, function blocks, to build applications more efficiently and make them easier to maintain.
Seems like this is more established in Europe, maybe, with companies like Siemens, Beckhoff really pushing it.
That's the perception, yeah. A stronger emphasis on creating and reusing these code modules.
Whereas perhaps in other regions, like Japan, where the original podcast was from, maybe the practice still leans more towards project-specific code.
That was suggested. Perhaps not fully leveraging reusable libraries as much as they could be.
Which has benefits, right? Encapsulating code, better quality control, easier reuse.
Definitely. But then there's the flip side. Should developers be forced to use function blocks? Or should they have the flexibility to write code directly if needed?
The classic standardization versus flexibility debate.
Pretty much. And even before you get to individual function blocks. Isn't the bigger picture the overall system architecture? Defining the units, the interfaces. The function blocks are just tools to implement that architecture.
That's a great point. You need the blueprint before you pick the tools.
And sometimes the problems aren't even about function blocks themselves. It might be deeper issues.
Like what?
Lack of proper testing methods, maybe poor documentation, no version control, things like that. Using function blocks won't fix those underlying process issues.
True. And relying only on vendor-provided libraries, is that always enough?
It's a good start, but if you're aiming for, say, 95% production efficiency, not just 80%,
you might need something more tailored.
You often need to tweak existing blocks or create completely new ones for that peak performance. Customization is key for optimization.
And sometimes the PLC systems themselves can get in the way, right? If they lack features like, say, inheritance in their programming models.
Yeah, that can make it really hard to adapt or extend existing code properly without just copying and pasting or breaking things.
So it makes code reuse much harder than it should be.
Exactly. So often, the core issue isn't the concept of modularity. It's the limitations in the development environment or the system architecture itself.
Okay. So summing up the future outlook, it really feels like continued convergence between IPCs and PLCs.
Yeah, the hardware lines will keep blurring.
And the real differentiators will be the software tools from the vendors, their quality, usability.
And the overall system architecture they enable, I think.
So the final choice isn't really about IPC or PLC as labels anymore?
Not fundamentally, no. It's driven by the specific application needs, the budget.
The software ecosystem you prefer, how much IT integration you actually need.
Right. It's not about a basic hardware capability difference so much anymore.
So there isn't one best solution that fits all?
Definitely not.
Well,
it demands really understanding your project goals. What's the long-term vision for this automation system?
you have to look beyond just the hardware specs.
Absolutely. Focus on the software tools, the development methods, and crucially, can you build code that's reusable and maintainable for the long haul?
Okay, so here's a final thought then for you listening. As IPCs and PLCs keep merging, will we even keep using these old names?
Interesting question.
Or will we see totally new kinds of industrial controllers emerge, maybe defined more by their software capabilities and architecture? What factors will you be weighing up when you design your next automation system?